All right, let's welcome to the stage our first talk today.
Okay, folks. See, you're all excited because it's what, day 2, day 3? But at AWS, it's always day 1, right? Exactly. See, you know. So we'll get through these fancy first few slides. Forward-looking statement. We always look forward, not backwards, right? Acknowledge our past, but we look towards the future. Another thing which we all love to fill out is surveys. But look, if we do a good job, let us know. If we do a bad job, let us know even more. And welcome to this presentation. It's called Well-Architected Data and AI Platforms. We've also got a special appearance by a customer called Ripple. I'm Rudy Chetty. I'm joined by Priyanka Adya and Hari Vignesh, who are going to come up and tell you their story of how they utilized Databricks and AWS in harmony. But to set the stage, let's give you some background, right? So you know what's going on. You know data is everywhere. It's everywhere. It's being generated in more and more amounts every day, every second. Just think about the amount of data you use on your phone, right? Especially if you're on Wi-Fi. The problem comes in is that we've got all this data, but how do we take that data and gain insights? That's the important part. Is you're like, well, we could just examine it manually, maybe an Excel spreadsheet. Even better, you could create a dedicated app. So with that app, you're actually sitting there going, oh, this is going to get the insights I need to pull out from here. And even better, you can utilize a platform like AWS to help you do that. Look at those services. It's only a handful that I've shown there. S3, we've got Amazon Q, QuickSight. Essentially, you get your data into AWS, and you can analyze it, generate insights, and as we like to say where I'm from, Bob's your uncle after that, right? But if you've got data and you're here at the Data and AI Summit, probably utilizing Databricks. Great platform, recommend it. Even better is you can develop all these apps in tandem with AWS and Databricks. But when you're developing them, and I'm sure some of you who are technical folks, you know this, consistent app development is very tricky. It's needed, but it's tricky. So what do I mean by that? Well, you got many moving pieces. You got your database. You got your other data that might not be in a database. Compute, everything under the sun. So you're thinking, well, can I do this alone? You could. Or you could take all your team members together and you can get the app developed quicker, faster, in a more stabilized, or as we say, standardized mechanism, right? You figure out how it works with your first workload, your next workload's a bit better. You keep iterating as you go forward, right? The way that you do that on AWS is through something we call the Well-Architected Framework, WAF for short. It's got 6 pillars. We'll go into them just now. But even better, apart from the standardized way of developing your apps on AWS, we have lenses, industry lenses. So it's like my lenses here. You can see they're kind of thick, right? But you put this lens in between the actual well-architected framework pillars and the workload you're running. It gives you additional insights into how you could potentially improve your application, how you can make sure it's reliable, and so forth. And like I said, that partnership, we want to stress it. Databricks and AWS. When you're putting your data into the Databricks platform or storing it on AWS or both, that's how you can accelerate your workloads. And as I mentioned, why Databricks on AWS? Well, it's the million-dollar question, right? Well, think about it like this. Databricks was born on AWS. Right? They've got a lot of experience developing and running their workloads there such that they provide that to customers like yourselves. Case in point here, innovations that come through Databricks, they usually debut on AWS first. And that's cool because you get the latest and greatest. For example here, SAP, or like I said, where I'm from, we actually say SAP because SAPS is South African Police Services. So if you say SAPs, they're like, oh, no, we don't want that, right? In addition, with this joint partnership, you get vertical solutions. Remember those industries I mentioned? All of those, healthcare, life sciences. You can go through manufacturing, IoT, you name it. It's been developed. And the best part is you can learn from those other customers or partners to enhance your workloads. You also get interoperability. So like I said, Databricks was born on AWS, so it's kind of cloud native. And then you take a step back and you're like, oh, it's using the same services that I'm used to now. S3, simple storage service. You can store all your data in a bucket. It just makes it that much easier and seamless, I should say, to integrate these features. In addition, you get a lower TCO. That's total cost of ownership. Examples here, you can see those two icons. One is EC2, specifically Graviton. We've got some 64-bit ARM-based CPUs. So if you convert your workloads to utilize that chipset architecture, you can actually lower your TCO just by utilizing that chipset. In addition, you can take advantage of spot instances, fleets, all of the lovely features that have been baked into services like EC2, Elastic Compute Cloud. You can also use something which is on the right there, S3 intelligent tiering. So remember the data that's sitting there? I'm telling you, some workloads, when people put their data there, they keep it. And they're like, well, this is 5 years old. Oh, we need it. Okay, I understand. Let's do a compromise. Let's tier it so that after 5 years, it moves to a lower storage tier, which is more cost effective. So you still have your data, but it's less TCO. That's how you start improving it. Remember, it's an evolving workload. And the hot topic now, I mean, it's baked into the actual title of the summit, Gen AI. You get access to Amazon SageMaker AI and Amazon Bedrock. So if you want to integrate those in, seamless, like I said. You can utilize foundation models, large language models, the ones that are general purpose, but they get you to where you want to go. Amazon Nova as well, Nova Sonic, you got access to all of that if you just spin it up on Bedrock. And one thing you might not know is Databricks was #1 on the AWS marketplace. So a lot of folks are using it. Well, I mean, that's why you're here, right? I can see that guy's excited. Yeah, I can see it in your eyes, right? You're excited. But well-architected framework. This is the last part we'll go over. Well, maybe 2 more slides. This here is comprised of 6 pillars that you evaluate applications or workloads against such that they're developed in a consistent manner, right? So you know that, oh, if I've gone through the well-architected framework while developing this, there's a better chance my app's going to be stable, reliable, all of the above. First one here, operational excellence. Is the application able to be monitored, run efficiently, and in the sense that, okay, it's operating. We've got more users now the next month. They keep going. It's operating well. It's operating with excellency. See? That's where it comes in. The next one, which very important, I'd argue this should be #1. Security. You don't want bad actors to have access to that data that you've created, put into an S3 bucket or whatnot. So make sure that when you're developing applications, you adhere to what we call the principle of least privileged access, which means if user A needs to read from database B, just give them read access. You don't have to go the other way and give them read, write, delete, all of that, CRUD access. No, bare minimum permissions. And that permeates throughout all your workloads, your applications. You also want applications to be reliable. Say there's a disruption in one of your workloads. Can your application recover gracefully without your users even knowing that there was a disruption? That's what we mean by reliable. And it is possible, utilizing multi-availability zones, multi-region. You could go all the way there. The 4th pillar, performance efficiency. Is your application performing how it should be as your workload, as your customer base, as everything that's involved evolves, right? Efficient performance. Because you never know. Maybe you started it 2 years ago. There's been feature enhancements or new CPU types that came out in EC2. If you changed them over to that one, oh, that makes it more efficient. That's the beauty of the cloud, is it's dynamic, it's evolving. You can change your workloads as your needs evolve, as your customers' needs evolve, and your business requirements. Never one and done. And we've talked a bit about this, cost optimization. Like I said, new features come out, new services. By switching to it or utilizing a different S3 bucket tier or S3 tier, I can save some money here, be more cost effective. I'm telling you, people will be like, oh, I'm saving money. Love you already, thank you, right? And the final one here is sustainability. We've got one world, one earth. We all want to grow together, be consistent, be mindful of what we're doing from an environmental perspective. So when you look at a specific region, you can check, are the resources that are being consumed sustainable? Are the energy resources clean? That's where sustainability comes in. And through all of this, right, like I said, Databricks was born on AWS, they took inspiration. They were like, we like this well-architected framework. We'd like to do something similar. So they created the well-architected lakehouse, right? I live in Seattle. There's a lot of lakehouses there. There's a lot of water, too. We actually call it the Puget Sound. And for the longest time, I kept listening outside my window when I moved. Like, what is it? I don't hear the sound. Like, sound is actually the body of water. So, well-architected lakehouse, and it is built on top of AWS WAF. Now, why do I have a snake there? It's to help you remember the acronym for well-architected framework. The way I remember is CORPS. You know, it's a snake. It's like CORPS. Cost optimization, operational efficiency, reliability, performance efficiency, security, sustainability. So if you're ever going for an exam, that's how you remember the acronym for well-architected framework. But, like I said, Databricks built on top. In this case, data and AI governance. That's the first pillar they added. So it's like, okay, well, is there oversight with the data and AI that is actually bringing value to my customers' workloads? Yes. In addition, this is the other one, interoperability and usability. Can you actually utilize this lakehouse architecture to interact with other systems? Is it that seamless, as I've said a few times? That's how you do it. And that's where that partnership with AWS and Databricks comes to the forefront. You're like, oh, I've got the well-architected framework, I've got the Databricks well-architected lakehouse. If I develop with these two technologies or companies or workload providers, however you want to describe it, you know, I'm pretty much already set from the start. I've got this to work on. But look, I'm not here to market to you. I'm here to tell you my experiences. Even better, this is where we bring up Ripple and we say, you know what? Hear from a customer. So not just from me, from the customer. So I'd like to welcome the Ripple engineering team, one at a time, to the stage. So I think you're up first, Priyanka. Yes, please come on. Please give a warm round of applause. There you go.
Thank you. Hello, everyone. I'm Priyanka Adhia, engineering manager at Ripple for the data team. Today, I'm going to share the journey of how we migrated from Hadoop architecture, Ripple's legacy architecture, to more fast, reliable platform, and how we saved cost and how we got there using Databricks and AWS. At Ripple, we we have high frequency ledger transactions at global scale. But until now, things were working, but we hit so many roadblocks. There were cost issues, there were performance issues, there were latency issues, you name it. And we know and we knew that we needed a change. We needed modern architecture. So let's start with where we were, our Hadoop-based system and the fragmented crowd services and what problems we saw in the legacy architecture. First, the maintenance overhead was significant. We faced performance bottleneck, latency issues, we faced auto-scaling failures. That meant high volume of support tickets, and we spent a lot of time firefighting. So secondly, we had real-time processing issues, right? So we couldn't have Hadoop ledger transaction, high ledger frequency transaction flowing in, and we couldn't support real-time workloads. The third one was peak business hours, especially during holiday times, there were high throughput issues. And then lastly, we had this fragmented architecture with multi-cloud data fragmented everywhere, leading to high cost and issues around supporting and maintenance. So these were the challenges we had. Now let's take a look at the dimensions with the new architecture, modern framework, right? We were focused on 4 core dimensions. We wanted to optimize on cost, we wanted to optimize on latency, we wanted to optimize on performance, and we wanted to optimize on high volume data using the modern architecture. And AWS and Databricks gave us that support and everything in terms of services and different, I would say, plethora of services that we needed to go for it. So let's take a look at that. Are we on? Yeah, so the first dimension is cost. With AWS, we saw flexible pay-as-you-go model, instances. We had multiple instance type, and we could use reserved instances. We could use a wide range of instance type. Right sizing, we could use Lambda, which was serverless feature. We also had Photon and Graviton combination, which accelerated our query processing. The Photon plus Graviton really did the magic. We saw like 3x price performance improvements, and it just did it magic. And then lastly, we also used Grafana, as well as we used Databricks system tables to measure our daily cost, as well as how we could optimize on our cost savings. That itself gave us about 80% reduction in cost. So the second dimension, let's take a look at the second dimension. The second dimension was on the performance. For performance optimization, we wanted Databricks, which gave us Apache Spark as the backbone for our machine learning workloads. Photon engine with vectorized execution help us extremely get to the extremely fast queries, and we could save about 55% month on month by moving to Photon. And then Delta Lake enabled, along with the autoloader, enabled the fast continuous pipelines to get there. Then the third dimension was latency. So AWS supported services like Kinesis, DynamoDB, which we blended together with our APIs, and that gave us highly fast workloads and latency up to seconds. Databricks also supports Spark structured streaming, which made our continuous workload scale at high speed, and we could really see real-time workloads in production, which was a huge win. And then lastly, we leveraged Delta Live tables, natively supported with autoloader for seamless end-to-end continuous workloads running in production. Now the fourth dimension was storage. Definitely storage was last piece of the puzzle, and we wanted to get it right. For storage, we had S3, and S3 was supported with intelligent tiering, with policies that could help us, archive data, put it into cold storage, so on and so forth. And then also we had integration with lake formation and glue, which help us made, a federated architecture with right governance and best practices in place. And then lastly, Databricks offered Delta Lake optimization capabilities, which was excellent when we saw things like Z skipping, and then Z ordering, high volume of ingestion workloads coming through, and we partitioned using those techniques for data skipping, file compaction, so on and so forth. And then lastly, we had S3 as backup, which eliminated our redundant storage and help us scale for high volume workloads. So with this, I would like to invite Hari, who will walk us through the architecture and how we got there.
Thank you, Priyanka. Hey guys, I am Hari Vignesh Rajendran, staff software engineer in Ripple's data platform team. I'll talk about the high-level architecture that we have with our data platform now. So we primarily have 3 ingestion methods, primary being the API-based ingestion, which integrates tightly with all the microservices that we have for various business units. The service teams or the engineering teams push the data to our Caspian, to the data platform API, which is actually backed by Amazon API Gateway, Lambda functions, Kinesis data streams, and Firehouse and S3. And also, we have the direct file-based ingestion in terms of when the data volume is large and the data file formats are like CSV, Parquet, and JSON. We allow cross-account access for teams to directly upload the files to S3 buckets. And also CDC-based ingestion, a lot of microservices within Ripple use my Amazon DynamoDB, and which puts the data into Kinesis data streams, again through cross-account access. Lambda function reads the data from Kinesis data streams and puts the data to Firehouse and puts the data to S3 there. And also, depending upon the latency requirements that our business use cases dictate, we either read the data from Kinesis data streams or from S3 through structured Spark streaming jobs or DLT, and which also moves the data to the Delta Lake, which is principled on top of bronze, silver, and gold tables, quote-unquote medallion architecture, which most of us will be following here. And once the data gets into the silver and gold tables, we also have the reporting layer and AIBA layers built on top of them. Also, we have observability. Nothing is complete without observability, let's say. And we have ETL stats dashboard, which measures the success failure rates. Delta Lake metrics, which talks about the size of the tables, the size of S3, storage that the table contributes, the vacuuming frequency, and other metrics there. And also job CPU and IO metrics, we launch all our compute on EC2 instances within our own account. So we also have the metrics captured for them as well. And also we have the other AWS infra for other workflows. We utilize EC2 instances, NAT gateway, SQS, SNS for monitoring, notifications, and our compute requirements. Okay, so let's talk about the business impact. So Priyanka talked about what was lacking in our previous data platform and what happened when we switched to this new data platform. Cost savings of more than $1 million was achieved in 2024 through both targeted optimizations for various cost drivers, as well as platform optimizations in AWS and Databricks that we put in, and improved developer productivity too. So in some cases, the feature delivery time decreased from few weeks to few days, and faster data delivery for stakeholders as well. From early batch pipelines that we had in our previous architecture, the data movement from ingestion API to gold tables was now done within a few seconds, and customers are now happy. So yeah, so how did we go about cost optimization, and how did we achieve the $1 million savings that I highlighted last slide? So first, we identified the various cost drivers within our platform. We observed that jobs, DLT pipelines, SQL queries, S3 storage, all-purpose clusters, some amount of model serving endpoint as well, but that was not a lot of cost, so I didn't include it here. But once these major cost drivers were identified, we were able to attribute these costs to various business units, and also we created dashboards for the various business units for all these cost drivers, and we calculated efficiency scores for each of them. So, which actually says that how efficiently the resources are being utilized. For example, how efficiently you're using a job, how we efficiently have created a DLT pipeline. And we created a formula out of it, which actually gave an overall view to the business units on what to target and what to optimize, and which pipeline, if you target, you'll get better savings and all kinds of insights there. So let's talk about the AWS optimizations, the platform optimizations. I think a portion of it was also covered by Priyanka. So we enabled S3 intelligent tiering for our S3 buckets and enable lifecycle policies for all the S3 buckets that we owned. So this actually had like 40% cost savings compared to the standard storage class, and 20% savings with Graviton EC2 instances compared to the x86 architecture instances that we were previously using. And also VPC gateway endpoints, we have enabled it for our S3 bucket access so that all our EC2 instances can access data from our S3 buckets in a cost-efficient, reliable, and secured manner. And also we tracked the Spark cluster usage as well. We made sure that we tagged all the clusters with the job IDs and the cluster IDs. We were able to roll it up to a particular job and DLT pipeline, and made sure that each and every job and DLT pipeline were utilizing the proper instance types and the EBS volumes there as well, and which would actually give us better cost per performance ratio. And also we were big on spot instances for our executors. So we, instead of using on-demand, we used the spot on fallback policy, which I will talk about, which helped us save like around 10% of money compared to the on-demand instances. Okay, let's talk about the cost savings that we applied through Databricks optimization. So we also set up monitoring on the S3 growth of the Databricks tables, and we enabled periodic vacuum jobs. In some cases, for example, the actual table was like few gigabytes, but previous versions of the data were several terabytes, and that was occupying a lot of storage space in our S3, which we promptly identified and implemented periodic vacuum jobs to clean them up. And also optimizing this executor memory of clusters. By this, what I mean is all stateful applications that we have. The state store growth was managed through watermarking, appropriate watermarking intervals, and we made sure that executor memory did not blow out of proportions, and we needed to add more executors all the time to satisfy the demand. Enabling auto-scaling, it's like a default policy within Databricks. So auto-scaling was enabled so that when the load is less, it can scale down, and when the load is more, it can scale up. And also we utilize Databricks cluster policy configurations as well, so very deeply. So we had multiple policies created for jobs and DLT pipelines, which had to be attached when the jobs and DLTs were started. Primarily, these settings were the ones that contributed to a lot of savings. We enforced pipeline's cluster shutdown delay setting to 2 minutes, so that when the job or when the DLT pipeline completes, it would shut down within 2 minutes. The cluster would shut down within 2 minutes. And also, we set the max value for DBUs per hour, so that if the user wants to launch bigger instance types and also more number of instances, it was the total DBUs are bound by the limit that we set here. And also, we set the node type ID to Graviton instances by default, both in cluster policy as well as Terraform modules as well. So that by default, if there was no cluster or instance type defined for executors, we use Graviton instances. And also, we use the spot with fallback as the default for our executor instances, as I defined earlier. So the Databricks system tables utilization, how did we utilize it? So we used it to track updates happening in the upstream tables. And based on that, we scheduled our downstream pipelines. In some cases, what we identified was the tables were getting updated every hour, but the downstream pipelines were running every 5 minutes, which means that they're always getting the older data in spite of running every 5 minutes, right? So we also adjusted the downstream pipeline scheduling based on the refresh rate of the upstream tables. And we also monitored the continuously running jobs in our lower environments and also jobs running for more than 14 days. And we alerted the job owners to take action to shut them down. And also we also lowered the SQL warehouse cost by monitoring long-running resource-intensive queries, analyze the query plan, and optimize the queries. So what's the conclusion? So the conclusion is improved processing speeds, P90 low latency use cases, which is like most of the use cases that we have. From ingestion API that I defined to the silver tables, it was less than 2 minutes. And for ultra low latency use cases, from ingestion API to the silver tables, it was less than 4 seconds. Higher reliability. So we utilized AWS, in our underlying architecture. So we expected near zero data loss due to the robust retry monitoring mechanisms that we had in place, and also reduced cost. So the cost in 2024 alone was 10 times lower, 10% lower compared to 2023. Despite like 12x daily volume of data and 270 terabytes of extra data that we processed. Yeah. So lastly, this is the last slide. So lastly, I would like to thank my team here. So thank you for your contributions towards building this new data platform here. So thank you very much.
Get the mic back up. Thank you. That was, see, remember what I told you at the beginning? The $1 million question? He answered it. They both answered it. They saved over $1 million. And you didn't realize that till the end of the presentation. But you can see, we're not just telling you how to utilize our platforms together. We're showing you through an actual customer example. And using Lambda, one of my favorite services. Do you know why it is? It always reminds me of a game I used to play in my youth. You can see there's some gray hair here, right? Called Half-Life. It's got that same symbol, the Lambda symbol. So think of this when you're developing your workloads. Relate the services to things that you can, think of in your everyday life. The other example that was mentioned was the S3 intelligent tiering option, where you can move data. A simple way to remember that is maybe you have a house, right? You got your fridge, you got your favorite drinks in there, maybe a Coke, LaCroix, mine's Topo Chico. Got my Topo Chico there. But you've got so many Topo Chicos, you want to store the rest of them somewhere else. So you store them in the fridge in your garage. That is S3 intelligent tiering. You still have access to both, but instead of going to your kitchen fridge, you have to go to your garage, take it out there. Both still very cold and tasty beverages. But before I digress into all of these analogies, I want to thank you for being here, listening to us talk about not only the well-architected framework that you can utilize on AWS, but also the 2 additional pillars that you can use with the well-architected lakehouse. And how do you approach it? You dip your toes in the water at the lakehouse, get a feel for it. Oh, okay, this is not so bad. Maybe you can dive in, you can go a bit further. And that's where you start to build out your architecture, just like the diagram that Hari showed. You start small, right? But you think big. It's one of our leadership principles, is think big. So think of it that way. You can always look at the end game, but the fun part is figuring it out in between. Start with that small workload, build on top, and cost optimize, performance efficiency, all of those well-architected pillars and the lakehouse pillars as well. Utilize them as your workload evolves. Because like I said, it's never one and done. So with that, I know I've got a few minutes. I'm standing between you and probably lunch. I know we fed your mind. Now I'm going to feed your belly. So go get your lunch on. Thank you again for joining us. Hopefully we'll see you again next year.